Hello everybody, welcome to my presentation. And my name is Sudhanshu Ranjan. I'm a software engineering lead in Aerospike. Today I'm going to make a presentation on our Aerospike Kubernetes Operator. So let's get started. And let me share my screen. Okay, so this is going to be the outline for our presentation. First, I'm going to talk about the goal and the motivation behind this Kubernetes operator. And then I will briefly talk about the operator functionality. And then we would have a demo. And at the end, we would have a Q&A session. So what is the goal and the motivation behind this operator? So the main job of this operator is to minimize the manual effort in deploying and doing the lifecycle management of Aerospike cluster. So there are a couple of things like scale down, upgrade, downgrade, flag management. So all the steps need some kind of operational knowledge. So you have to follow certain steps to complete these tasks, and those steps can be pretty complex, and they may go wrong also. So the whole idea was to automate all that flow and put it in the respective Kubernetes operator, so that human operator can easily manage respect cluster. Okay, so before going ahead, I will like to tell you that I'm not going to cover the basics of Kubernetes. I assume that people sitting here have a basic understanding of the Kubernetes and its concept, like pod deployment, stateful set, and basic understanding about how operator works. And I'm also not going to cover the theoretical aspect and the architectural part of the Kubernetes operator. So if you want to look at that, then there is a wonderful session by my colleague Ashish. He has covered the architectural part of this operator very nicely. So you can go and check that out. Okay, so what are the operator functionalities? So it can do the deployment of Aerospike cluster. It can do the life cycle management of Aerospike cluster, like it can do the scale down, scale up, Aerospike version upgrade, downgrade, and then it can also do the Aerospike configuration management. Like you can change any of your Aerospike config from the main YAML file, and you can apply it, and that will be applied to your Aerospike cluster. It can also do the rack management from the config itself, and you can also do the Aerospike access control management from the operator. You can add a user, you can add a role, you can remove, you can add the privileges to the users, you can change the password of the user. So all that can be done by this operator. Okay, so the next is this multi-cluster setup. So operator can manage multiple Aerospike cluster, and they can be in a single namespace, single Kubernetes namespace, or they can be in multiple Kubernetes namespace. Operator can manage all of them. And for that purpose, I will show you a XDR setup where source and destination both are managed with the same operator. And yeah, we also support the monitoring of the cluster deployed with this operator. We have our Aerospike monitoring stack, and that can be integrated with this Kubernetes operator deployed Aerospike clusters, so you can monitor those. Okay, so for the purpose of this workshop, I have created a Git repo where there are a couple of files and complete documentation which you can follow. So let's go there. Okay, so let me put it somewhere, maybe here. Okay, so there is this Git repo, and here this is the main documentation. And I have listed all the steps, like how you can create a Kubernetes cluster, how you can get the operator, then deploy the operator, then deploy the cluster, everything. Okay, so let's go step by step. So first is that you have to create a Kubernetes cluster. Okay, so currently we support these cloud service providers. So we can deploy our Respect cluster in the Amazon EKS, then Microsoft Azure, and the Google GKE. So for the purpose of this workshop, I have already created a Kubernetes cluster in the GKE. So they are the nodes which are running. So you can see that there are 3 nodes which are in US West 2A, and there are 3 nodes which are in US West 2B. So this will be important while we would do the rack management, this cluster. Okay, so the second thing is that you have to get the operator from the Git, and for that you have to clone our Kubernetes operator repo and check out this flag. Okay, so I have already cloned that Git repo so that we can save some time, and you can just follow this step and get it. Okay, so the next thing is deploy the operator. So for that, I'll go here, and here all the required files are in this deploy folder. So I will create a Kubernetes namespace, then I will register the Aerospike custom resource definition. This is required by the Kubernetes to understand our Aerospike cluster custom resource. And the third is this role-based access control. So this is going to regulate the uh, access or the permissions of this operator in this Kubernetes cluster. So let's go and apply all of these. Okay, so this is our operator.yaml file, which is in deploy folder in this repo. So let's deploy this operator, and we can see this operator getting deployed. And, okay, so we can see that now we have one pod running for the operator, and you can also check the logs using this command. I am just going ahead. Okay, so we have our Aerospike Kubernetes operator ready. So the next step is to deploy the Aerospike cluster. So for that, there are a couple of prerequisites. So first is that you have to create a storage class, which will be used by Aerospike clusters to claim its storage. So I'm going to create this storage class. Okay, so this is created. And the next thing is that you have to create some secrets. So there are two types of secrets. So one is a generic secret where you can put all of your Aerospike related secret information, like you can put the TLS certificates, you can put the feature.conf, which is required in this enterprise cluster. And then other secret is for the password for your user. Okay, so here this feature.conf is required. So first I'm just going to copy my feature key file. Okay, so if you have to run your enterprise cluster, then you would be given Secrets. Okay. Okay, so here we have our feature.com. So I'm copying it here. Okay, so let's create this secret. Okay, this is created, and now let's create this secret for the user. So this is we will use for the user admin, and this is the password which we have to put in the secret. Okay, so this is also created. So next is creating this respect cluster. So for that, we have a custom. So this respect cluster is the custom resource, this operator word. And in this custom resource, you can manage all the configs related to this respect cluster. So you can mention the size for the cluster. You can mention the image which you want to run in this cluster. And then you can also give the Aerospike access control config. You can mention the user and its roles, and they are the secrets which we have just created. And this is the Aerospike config, which if you have used Aerospike cluster, then you would have uh, seen our aerospike.conf file. So this is just the YAML representation of that file. And then you can mention the resources for the every pod. And this is something which I will explain in the monitoring section, because this is related to the monitoring. So let's copy some of the files which I have already created in in the Git repo, and then let's use those files. And this sort of create a respect cluster. Okay, so we can see that there is this 0, 0 and 0, 1. So they are the two nodes which are coming up, and they are getting initialized. Okay, so let me explain you the numbers. So the first is the rack ID. So if there is no rack, then by default it will take the 0. And then the second is the pod index in that rack. So this is the first pod, this is the first pod in this rack, and this is the second pod in this rack. Okay, so now we have our both of the nodes for this Aerospike cluster running. So let's see how we have to connect to this cluster. So if you have to get the connection endpoint, then you can just do the describe, and the describe in the status section, you will find the access points and alternate access point. Sorry. And you can use these depending on from where you want to access this Aerospike cluster. And the other way to access this cluster is by using our Aerospike tools image. So I'm going to use this. This will create a Aerospike tools pod, and in that pod I can run this ASADM command, and there I will be able to see about my Aerospike cluster information. So it is getting created. So let's wait for a second and it's come up. Okay, so let's do info, and yeah, this is this sort window. So this will be a little bit cluttered, but let me just explain. Okay, so this is they are the two nodes, and this is the cluster name, and this is the node name first, and then this is the node ID, and this is the image which we are running in that node. So you can see that with this we have been able to connect with this. So let's try out the monitoring of this Aerospike cluster. So here we are going to integrate our Aerospike monitoring stack with this Aerospike cluster. So for that, you will need this help. And with the Helm, we are going to run this Spike Marketing Stack Helm chart. Okay, so what is the method? How we are going to monitor it? So first requirement is that you have to add a pod spec in the custom resource file. So this pod spec will trigger a rolling restart, and then this sidecar, this is the Aerospike Prometheus exporter. This sidecar will be added in every Aerospike cluster parts. So they will be able to fetch, this sidecar will be able to fetch the metrics from the Aerospike cluster nodes, and then this will be able to give those metrics to the external monitoring stack. So because so this thing I have already added, which I told you in the previous Aspect cluster deployment. So I'm going to skip this step. And the next part is deploying the monitoring stack. So usually people have their own monitoring stack, so they can just use that stack, and from there they can they can configure that stack so that that monitoring stack can find out the respect cluster parts, and then it can request the exporter for these metrics. So here I have created one monitoring stack for me. Okay, so let's do this. And probably this was already added, so it has skipped it. So the next thing is this config of Aerospike monitoring stack. So here you see that with this config, it is able to find out the Aerospike cluster parts. So here it is selecting the Kubernetes namespace where all the pods are running, and this is where it is taking the labels in the pods. So all the Aerospike cluster pods have this Aerospike cluster label, and the third is this exporter exporter port, which we have added this pod spec. So with this port, the aspect monitoring stack will fetch the metrics. Okay, so let's apply this. Okay, so this would create three different parts. One would be for alert manager, one would be for Grafana, and one would be for Prometheus. So these parts will be running, and they will be making uh, request to the Prometheus exporter sidecar, which we have added in our Aspect cluster parts. So we see that they are coming up and they will be running. Okay, so now let's look at this Grafana dashboard. So for this, I'm doing this port forwarding so that I can access this Grafana dashboard from here only. Okay, so let's okay, so let's log in. Let's get this. And here, let's look at the cluster overview. Yeah. Okay, so we can see that there are two cluster nodes, and the name of the cluster is this Aero cluster, and they are the version of the Aerospike cluster nodes. And you can also look at namespace view or the node view, which we would see in the other examples. Okay, so we have integrated our Aerospike monitoring stack in this. Okay, so next step is to scale up the Aerospike cluster. And this is as simple as that. You have to change the size in the custom source file, and then you have to apply it, and it will bring up one more node. So let's do it here. Okay, so let's make it 4. Just apply it, and it should launch 2 more pods. It should be Aero cluster 03 and 02. Oh, I'm sorry. I think I have changed this in a different cluster. So this is this Aerospike cluster which we have deployed. So let's make it 4 and apply it. And you'll be able to see the parts here. Okay, so we can see there are 2 parts which are coming up, the 02 and 03. So for any change in the Aerospike cluster, you have to just change this config file here, and you have to apply it, and then Aerospike operator will try to bring your Aerospike cluster as close as possible with this specification. Okay, so looks like we have this 2 running and then 3 running also. So let's check and okay, so in the monitoring also we can see that the cluster size is 4. Okay, so the next thing is the scale down. So we can just change this to the 3, and we can reapply it, and this should bring down one Aerospike cluster node, which would be the last one. Okay, so now this is some step where if a human operator has to do, then he has to follow certain steps. For example, he has to make sure that Aerospike cluster is stable. He has to make sure if there are 0 migrations, and he has to do twice of the node so that no new transactions go in that node. So all those things are taken care of by this Kubernetes operator. So that's why takes a little bit of time in bringing down the node, and that time will depend on how many migrations are going on and how much time it will take to finish those. So here we are not having much data. So so this 03 has came down, and even in the monitoring also it should okay, I think we have to make it quicker. Okay, so we can see that the cluster size is now 3. Okay, so the next step is the upgrade. So upgrade is also as simple as this, that you have to change the image and you have to apply it. Okay, so we have changed this image, and we are going to apply it, and what it will do is that it will do a rolling restart of all the cluster nodes, and all the nodes will come up with the new image. So here is okay, so we would be able to see that after a while the 02 will go down, and it will come up with the new image, then 01 will do the same, and then 0 will do the same. So let's look at the monitoring and see what is happening there. Okay, so let's look at the node view. It is taking a bit of time. Okay, so we can see this 02 has started terminating, and then it will come up with the new image. So in the monitoring, here you can let's pull it quickly, and we would be able to see that all the build will change to 5.5. Okay, so one node is down, and it should come up with the new image. Okay, so we can see that one node is upgraded, and then it has started terminating 0, 1, and that will also go down from here, and that will also come up with the 5.5. So that's the beauty of Aerospike Kubernetes Operator, that it will do all the safety checks, and it will not bring down a node until unless it's not safe. So when it is safe, then only it will bring down the node, and it will also do all the steps which it has to follow for doing those things. So human operator does not have to bother about that. Okay, so we can see that two of the nodes are upgraded. Okay, so this has also started running, so this should come up here. Okay, so we can see over all of the Aerospike nodes are now upgraded. So let's move ahead with the next functionality. So okay, so this is one of the important feature of this Kubernetes operator, that you can roll back your partial upgrade or config update, or even the scale down if you have started. So what is the use case? So suppose you want to upgrade your aspect cluster image, and you have a 10 node, 20 node cluster, and operator has upgraded 2 or 3 of your node, and then suddenly you change your mind and you realize that you don't want this image anymore. So operator gives you the capability of rolling that back. So what are the steps for this? So the steps are going to be that you have to change the image, then you have to wait for few nodes to upgrade, and then you will again change back your image, and you will again apply it. So what will happen is that now operator will restart only those nodes which were upgraded to a new image. It will not touch the older nodes which are still in that older version. So let's try it out. So suppose you want to do the downgrade to 5.4, okay, and let's apply it, and then you'll be able to see that after a time it will start terminating the 0.2. Okay, so our 0.2 is coming down, and then you change your mind that no, you don't want this image anymore. So you can make it okay, a new image, and then you reapply it. You see that here 02 has came up with the 5.4. It should be probably visible here that one node is in the 5.4 and two are in 5.5. So yeah, so in the last step, I think it started terminating this 0.1 also. So this node will went to the 5.4 and it should not touch this 0.0 because this node was not upgraded to the 5.4. Okay, so from the last step, we have this two of the nodes in the 5.4. And now the expectation from the operator is that it will bring down the 0.2 and it will restart this with the 5.5 because we have rolled back that upgrade. It will also restart this 0.1 and you see that 0.0 has remained untouched. So this would be very helpful if you have a really big cluster. That suppose you have a 50 node cluster and you have created 3-4 nodes and in between you change your mind, then you will be able to quickly roll that back. Okay, so in the meantime, let's look at what is the next is okay. So here this 0.1 has gone down and it will also come with the 5.5. Okay, now it should not do anything with the 0.0. So we have all the nodes in the 5.5. So let's go to the next step. And next step is updating the config from the CR file. So that we can do simply that we have to just update this Aerospike config section in the CR file. So for this demo purpose, I will try to add an in-memory namespace bar. And just as a note that we do not allow a persistent storage namespace to be added dynamically because for that we have some kind of restriction from the Kubernetes side, so that is not yet supported. But we can add an in-memory namespace. So let's go and add that here, and let's also reduce the size of this. So what it will do is that first it will scale down the cluster. It will remove one node. And it will make the cluster size to the 2. And then it will do the rolling restart of remaining of the 2 node and apply this new config into those nodes. So the procedure here is same, that will look if the cluster is stable for starting a rolling restart. And if it finds that the cluster is not stable, there are migrations going on, it will wait for them to finish. When that will happen, then only it will bring down a node. So, okay, so here 02 is gone, and then that node should not come back, and it will do a rolling restart of 01 and 00. Okay, so now it has started doing the rolling restart of 01. So let's look at the namespace view, because earlier we were having just a test namespace, and change this. Okay, once one of the node will come up, then here one of the one more namespace would be added. That would be namespace bar. Okay, so we're just getting updated. So now we have this namespace test and namespace bar, which is added just recently. Okay, so next thing is this rack management. So the rack config is simple. You have to add this in the CR file, and then you have to do any change if you want to do, and then you can apply it. So here, so in the rack config, you can pass the list of namespaces which you want to make them rack aware, and then in the racks you can give the list of racks. This is the rack ID, and then every rack you can make based on a zone uh, uh, or the post label, rack label. You can give a label to all of your nodes in one rack, and then you can give another label to all of the nodes in another rack, and you can give that label here, and it will deploy all the parts accordingly. So here I told you that my cluster is having uh, two zones. One is this US West 2A and US West 2B. So I will apply it, and the size is 2. So let me tell you how it is going to work. So the expectation from the operator is now that it will bring up one node in the rack 1 and one node in the rack 2, and it should remove the previous nodes which were running in any other nodes. So you can see that there is uh, this one node which is coming up in the rack 1, and when this will be running, then it will go to the rack 2 and also start one node in that rack. So operator try to divide the cluster size as equally as possible between all the racks. So if you have a cluster size 3, then two nodes will come up in the rack 1 and one will come in the rack 2. And if you have a cluster size 4, then two nodes will go in this rack 1 and two nodes will go in this rack 2. Okay, so we have this one node in rack 1 and one node in rack 2, and it's start terminating the older racks, older nodes. So again, it will be waiting, looking if the cluster is stable or not. Okay, so it has started terminating the nodes. So let's check where are the all the parts which we have. For that, let's look at this GC cluster. This browser, and this Aerospike namespace. And the spec namespace, they are the parts which are running. So these two parts are the one which we have started. So this should be in the rack 1, this should be in the rack 2. So let's look at the nodes. So they are the 6 nodes which we have. So in any one of the, okay, so from the pod itself, we can look at the node. So let's see where it is running. Okay, so this pod is running in this node, which is the US based 2A. Okay, so let's look at the other pod. Just checking with you. Okay, so this is in US based 2B, and it is as expected because rack 1 is in the 2A and rack 2 is in the 2B. This rack 1 is in the 2A and rack 2 is in the 2B. So operator has deployed 2 racks successfully, and it has also removed the previous nodes. Okay, so let's look at what are the other steps which we have to do. Okay, so the next is this access control management. So here you can add a role, you can add the users, you can add or change the privileges, and you can apply it, and this will be done in a fraction of the second. So let's suppose we are going to add this role. So this is our access control section in this Aerospike cluster, and let's add this role, and then let's apply it. Okay, so this is applied. So let's verify it using our AQL. So for that, we can run this AQL tool again and connect to this cluster. And I have added this profiler role, okay, with this privilege. So here I should be able to see the role like this profiler and with this privileges. Okay, so now we have this tool running. So okay, so you can see that there is this profiler, the privilege read. Yeah, so that role is added. So now the next item is to create a user with the role. So here I am trying to create a profile user, which is using this role, and it is going to take the password from this profile user secret. So for that, I have to first create this secret with the password for this user. So I have created it, and then let's add this user. And then let's convert this. Yeah, this one. Let's apply it, and let's look in the SQL. So users. Okay, so we can see that we have a profile user, and the role is the profiler, which we want. Profile user and the role is profiler. So this is pretty simple. This access control thing is pretty simple to manage from the operator. Okay, so the next thing is this changing user's password. So this is also very simple. You have to just create a new secret with a new password, and then you have to change the secret name here and then apply it. And operator will apply this password to your cluster. So this thing probably you can do it yourself. So I can move ahead to the new item. Okay, so this is the last item in the list, that is the multi-cluster setup. So here I told that Aerospike Operator is capable of managing multiple Aerospike clusters. They can be deployed in a single Kubernetes namespace, or they can be deployed in multiple Kubernetes namespaces. So first, you have to deploy a destination cluster, and for that thing, I will use the existing cluster as a destination cluster, and I will just deploy another source cluster. So for the source cluster, what do you need? So in the source cluster, there are two things which you have to mention. So first, that you have to mention this whole idea section so that it can connect to the destination cluster. You have to mention the node names of the destination clusters, and then you have to also give the user and password so that it can write the data on that cluster. And then this is the source cluster which I will use. And just remember that you have to have this password in your source cluster. So in the source cluster, you will put it in the secret which we created for the features key file. So the secret which I earlier created, that secret already has this, so I don't have to create a new secret. But if you don't have that, then you can create a new secret and or just update that secret and put the file there. Okay, so let's look at the idea source file, and this is the file which I'm going to apply. So let's just apply this, and it should add two nodes cluster as a source cluster. Okay, so we can see that there is one node 00 which is coming up, and there is another node 01 which is coming up, and this cluster also has that sidecar of Prometheus exporter, so we would be able to monitor this cluster also in our Grafana. So we can just look, and probably we'll be able to see that in a while. Let's look at the cluster overview. Okay, so let's change it to. Okay, so we have this Aerospike source cluster which has came up, and there are two nodes, and this is in 5.5. Okay, so now let's add some data in the source cluster so that we can see if it is able to properly replicate the data to destination cluster. Okay, so with this command, you can connect to the cluster, and then there is this command, this benchmark, and which let's just run it. And this benchmark is also going to use the same tools image, and it will start load in the source cluster. You can see that the name here is the respect cluster source. This is the cluster which we have made as a source. So it has started the load, write, and the reads. So uh, let's go and look at the HDR. Okay, so in the source cluster, and then change it 5 seconds, make it 5 minutes. Okay, so we can see that we can see the throughput in that source cluster, and we can also see the success. And if you would look at the namespace view, Then this bar is not having the HDR, so so the data here will be empty. There is no objects. So let's look at this. Let's change it. And let's make it final. So we can see the client writes which are happening. And so see the memory trend is increasing. So it has started. Okay, so in the here, let's see. It is entering just 1,000 records and then running a load over all those 1,000 records. So that's why we are seeing only the 1,000 records here. And this is the destination cluster, which is having the replicated record, and the source cluster also will be able to see the same thing. Refresh it. Okay, so we can see that here also we have this novel train, and then is one can record. Then you can see the client read, writes all the load which is going through. Okay, so with this we have come to the end of our demo, and I hope you all have enjoyed it. So now we are going to have a QA session. So please stay on.
All right, thank you, Sudhanshu, for this impressive demo. It must not be easy to juggle between all those different shells and then also, showing the all the statistics live. So Sudhanshu unfortunately couldn't join us for the Q&A, but we have Joe and Ashish. So thanks for joining, guys. So Joe and Ashish work with Sudhanshu in the ecosystem team. So please do not hesitate to ask questions. We had one so far. Hopefully we'll have some more. Otherwise, I have some that I will ask myself. So, all right. So the first question that I have, because I know this happens fairly regularly, what if I mistakenly apply something wrong in the resource file? Let's say a wrong Aerospike server version. So how does the operator handle that?
So there are two things. So the way the configuration could be wrong is if the entry itself is invalid. So for example, if you specify Aerospike version which doesn't exist, then the operator will upfront give you an error saying that you have entered an invalid configuration. If you have given a valid configuration but that's a mistake, then you can actually roll back the configuration again by making a fix and reapplying the configuration. The operator would roll back the work if it's not finished running through the entire cluster with your wrong configuration. Then it will just roll back the nodes that it has acted on. So you have a way to fix the mistake.
Thank you. So another question, and I know there's occasionally, not frequently, but occasionally there are like very special steps to do when a cluster has to be upgraded. So sometimes there's jump version, or the storage have to be wiped out, or cold start have to happen. So again, not frequent, but this happens. And working in support, I know this gets in the way frequently of customers either double checking their steps or like, missing a step. So does the operator handle those?
The operator currently supports Aerospike versions 4.6 upwards. So we have not yet hit a version which is a jump version or which requires some special cleanup before doing upgrade. But whenever that happens in the future, the operator would support those special steps for doing the upgrade.
Okay. So from 4.6, I know to get to 5.x and above, so there's a jump version. So that is something the operator will, force you, make sure that doesn't let you do the mistake of going from, let's say, 4.8 and then start like, rolling in 5.1.
Currently the one jump version that we have, it's a simple thing where we don't need any extra cleanup. So the operator just prevents you from doing a wrong jump. So probably it will not allow you to jump from 4.6 to 5.0.
Okay, great.
So
so that's already very useful because we, sometimes it's easy to miss those things. So thanks. So let's see. So don't be shy if there's question from the audience. I'm looking here, nothing else. So I'll continue, have maybe one or two more. So is it possible to, this is also something that often happens where customer wants to resize a namespace, so change, whether it's a memory that's allocated to a namespace or the storage details. Is that something that operator handles?
Yeah, so for completely in-memory namespaces, you could change the memory allocation without any issues. For changing the persistent storage allocated to a namespace, currently because the operator uses something called as a stateful set from Kubernetes, which does not allow you to resize persistent storage once it's created. So we have a slight issue there. We are waiting on the stateful set implementation to allow that feature. But we do have a workaround. The workaround is you could create another rack with the upgraded storage requirement. So you could have another rack which has more storage allocated for the same namespace. And once the new rack is up, you could remove the previous rack. So that way, effectively, you will have your namespaces resized. You just have to go through a little more elaborate procedure to do that. There's a workaround. Once Kubernetes allows you to resize namespace persistent storage from a stateful set, that should be easier. Resizing namespaces should be easier.
All right, thank you. Yeah, I guess
that's said that process is not so complicated. It's a fairly straightforward integration step in your configuration. So when you're doing that, the important thing is having the right enough size. But other than that, steps are through adding a rack, removing a rack.
Right. Yeah, I guess the workaround, I mean, it's not always necessarily a workaround of adding a rack is, then a lot of other configuration can be changed like that and a fairly easy way. So let's see. So one question here. So let me read it for you guys. How will the client application interact with the Aerospike cluster? Will it be within the same VPC as another pod? Or Ashish, you had mentioned Kubernetes service via load balancer, but we prefer our client library not to go through a load balancer. Can you comment on recommended way of enabling applications?
We do support two modes in which clients can actually talk to the Aerospike cluster. If the client is running within the same Kubernetes cluster, then it's simple. You can enable the client to use an option called pod network, which means that Aerospike service will be accessible using the pod's internal Kubernetes IP for clients. The option is you could use the Kubernetes nodes IP to access the Aerospike instances. So both these options are there. They are configurable. So you could choose one of these two. So you could configure the server when you're configuring the cluster Aerospike custom resource. You could specify these networking options. So what you can specify is for access address, should you use the pod internal addresses or the host external address? Similarly, for alternate access addresses, you could choose the pod address or the Kubernetes host or Kubernetes nodes IP addresses. So you could get it to work either ways, depending on where your clients are.
Right, thank you. So we're almost run out of time. Maybe one last quick one. I know we have some of the features like all flash PMAM. Can you comment on that? I don't know if those are supported or they're in the work. Any input?
Yeah, so PMM support both for index as well as the data is in the works. All flash, we need a few more privileged specific things that need to happen both from the server and the operator as well to get it to work. So both of these features, all flash and PMM, are in the works.
All right, thank
Yeah,
you.
current version doesn't support it. Yeah.
Okay. All right, thank you. So looking forward to those, and yeah, really looking forward to our users leveraging the operator. So I think we're just come up on time. So yeah, and if thanks to the audience, if more questions, you know where to find us in the networking part of in the summit, and enjoy the end of the summit. Thank you.